So for this one, we're gonna look at how we get this. When I look at the title, we're gonna do the imaginary number part, okay? All right, so we're gonna start off, by doing something just very simple. I said, let's try to square some numbers, or not, they should say numbers. So if I square 4, which would be 4 times 4, I get 16. I can actually, if I should write this. So this is the same as 4 squared. When you get 4 squared, it's 16. And then, but when I square negative 4, and always put negative numbers in parentheses. What's negative 4 times negative 4? What do we get? Positive 16, okay? When I square positive 4, I get 16, and when I square negative 4, I also get 16. Because negative times negative is a positive, right? So no matter what my numbers are, when I square something, my results are always going to be positive. There's no way for me to get a negative number this way. Okay? So here I had 7.7 squared. Okay, and then here you have negative 7.7 squared, and you get a positive 59.29. Let me just do a little calculator thing here. When plugging in, or I should say when we are taking the square of a negative number, we always have to use parentheses. Okay? Always have to use parentheses. I see students doing this a lot. They'll forget the parentheses, especially when it's a negative number, and then they get a wrong answer. And let me just show you why that is in your calculator. So in my calculator, if I plug in 4 squared, the square button's right there, I get 16, but then when I put negative 4 squared, I know my answer should be positive 16, but if I hit enter, I get negative 16 also. The reason is that it takes the square and it only puts it to this 4 right here. It doesn't read the negative, okay? So to avoid those, we just make sure you always put negative 4, close the parentheses, and then square it so that it reads that negative 4 and you get your positive. And then sometimes I have students doing this. They say, all right, well, I'll put in parentheses, and then they put in parentheses, but they leave the square inside the parentheses. And if you hit enter, it's the same, you'll get the same error, okay? So put your negative number inside of the parentheses and then put your square on the outside so that you don't run into this trouble. All right, so that's my little thing on negative and squares. And same thing with when you have variables, x squared, you're going to get a positive. When you have negative x times negative x, you'll get positive x squared. The negatives goes away. Okay? So this is where the imaginary number comes in. So it says here the result is always a positive number. So when we take the square root of a negative number, we cannot get a number back, right? Because if I say, well, what is the square root of negative 9? We can't. It's always going to be a positive, okay? So this is where they came up with the imaginary number. But imagine a number I where it can do this. So let's say that you take a number I and you multiply it by itself, and then you get negative 1. You get a negative answer. It's not in the real number line. You can't find it. It doesn't really exist. But it's just something that we use so that we can take negative square roots like these examples over here. And I'll show you how to do that. So all that to say, I is equal to square root of negative 1. Okay? This is always going to be what I is equal to. And so this is, square root of negative 1. We know that I is square root of negative 1 is I, so I love math. Okay, whatever. So now I'm going to show you how do we use the I. So over here, I'm going to have to rewrite, if I have a negative under my radical, I have to rewrite the problem like this. I have to say square root of -1, take care of the negative part, multiplied by square root of 9. Okay, we need to get rid of the negative on the 9. So to do that, we just kind of take it apart and put square root of -1. What is square root of -1 equal to? I. Okay, so I. And then what is square root of 9 equal to? 3. So we usually like to write 3 and then you write the I after it. So this is my answer. Okay.
What happens to the -9, the negative sign?
In the 9 right here, it goes away. It gets, it's in the I. This I automatically means it's the negative sign. Okay. You know, we just can't have a negative under the right. We have to put the 1 so that it goes. All right. So how do I find? How am I able to use the I in my calculator? So this is where you have to change the mode in your calculator. So when you sit down for with your calculator, you're gonna reset your calculator, right? Reset. So once you do that, you have to go to the mode right here. Mode, and then change it from go down towards the middle. You see where the real part is blinking? We want to change that to A plus BI. So go to mode. I'll quit again. So go to mode and then go change it to from real to A plus BI. And also just remember that, like, if you don't have a calculator, you can never take my calculators from this classroom. But if you need a calculator, the library has calculators you can check out. Okay, just throwing that out there. And it's the same stuff here. And then you just hit second mode to quit. And then now, if you look up here on your calculator, it should say A plus BI. Okay, when you hit reset, it's going to go back to the real up here. You never want it on real. You always want it on A plus BI. Okay. Record. Now, once I'm in my A plus BI mode, I can just plug this in my calculator and it'll give you the I. So -16, it calculates it for you and you get 4I. And then let's do square root of -1, -100. That should say 10I. And then, do you guys know the square root of 169? 13. So this should say 13I. And the I is because of the negative. What about if I put 4 square root of -25 in here? What do I get? 20. I? You better have the I in there. 20I. Alright, what about this one? Square root of -18. You can't have a decimal. I mean, this is a decimal form, but in my answer, when I write it out, you cannot write it in a decimal. So we have to, simplify this radical. Alright, so watch how I do this. So what I'm going to do is I'm going to take care of the negative part first. So I'm going to say square root of -1 and then square root of 18. And then the square root of 18, I have to look for perfect squares in 18. What's perfect square in 18? It goes into 18. 9 and 2. Yep. 9 is a perfect square. And again, if you look behind me on the board, there are a bunch of perfect squares up there. So you have, this is I, and I'm going to rewrite this as square root of 9 times square root of 2. All right, what is square root of 9? 3? Yep. So you have 3, you have the I, and you have the square root. I can't simplify this anymore. So now I'm just going to write it in a neat way. So you 3I square root of 2. Okay, so these are my answers. I want to check my answer here. So what I'm going to do is, in my calculator, when I plug it in, I have 4.2426 blah, 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 with the I. And then if I plug in my answer that I got, 3, the I that you want to use it's above the decimal. Do you see above the decimal? There's a little I there. So it's in blue. So hit second decimal to get that I. And then do square root of 2. And then you should get the same exact decimal, including the I. 8. So for number 7, I have 2, I'm going to leave that alone, multiplied by square root of negative 1 times square root of 72. Alright, I got to break down 72. So 72, let me look up the factors. 72 divided by x, table, let's see, 36. So we can do 2 and 36. So just bring everything down, bring down the 2. I'm just going to turn this into a I, because that's what it's equal to. And then you have square root of 2 and then square root of 36.
Can't simplify 36.
Yeah, we have to actually. Yep. Which is 6. Now you're going to put everything together. Put the 2 and 6 together. When I say put it together, it's being multiplied together. 2 times 6 is 12. And then put the I to take care of the negative part here. And then square root of 2. Okay? So 2 square root of negative 72 is equivalent to 2I square root of 2. I'm going to go ahead and check it in my calculator. 2 square root of negative 72. Enter. I get some decimal. And then I'm going to plug in my answer. 12 I second decimal square root of 2. Hit enter. And then all the decimal, everything should match, including the I. Are you guys starting to get the same numbers? Like, you know, what I mean by, okay. Yeah. Okay, I see some of you want to throw the calculators out the window. Just, it's okay. Well, you can stop if to the third column, okay? So if I say I square root of 1, what did you guys get? Just I by itself. And that makes sense because anything to the first power is always itself. So this should say I. And when I do square I squared is equal to negative 1. The reason is because, you know, when you have square root of negative 1 multiplied by square root of negative 1, the square roots go away and you just have negative 1. Okay, but that's fine. If you just put it in your calculator, you get negative 1. What about I square root of 3? What you guys get? Negative I. And then I to the 4th power? 1. I to the 5th? I. This is? This one? Yep. And then this one? 1. What about this column? Same thing, same thing. So it's a cycle. And then 1. You know, and then if you keep going, you will keep getting the same thing here. Because it always depends on the exponent. Okay, whatever your exponent is, it's basically divisible by 4, and then you look at the I. So here's a little trick that I use. I look at the exponent and I divide it by 4. and then I look at the decimal part, and then that's where I just use this chart to find what my answer is. Or, you know, you can always just plug it in your calculator, okay? No. So then you would just plug it in, right? I don't know. Sometimes students memorize it. So, I'm going to show you why we get these numbers with some examples, okay? All right, so what I'm going to do is I'm going to take 7, I'm going to divide it by 4. 7 divided by 4 is not a perfect number, or you'll get a decimal. 1.75, right? What that means is here I can rewrite 4. Well, I don't want to do all that. Let me just say that 0.75 is equal to negative I. Okay, so like for this one, I to the 9th power, what do you guys get for this? It's just I. Okay, you can plug this in your calculator. You don't have to do all of them, but I do want to jump to 9 and 10. Plug this in your calculator. I to the 102. What'd you get?
Negative 1.
Some weird thing, right? So the way I read this is, this e to the negative 13 is basically, it's like saying 0, because a very tiny number, but to you all that means is a 0. So if I take this part out, what do I have left here? Just negative 1. So the answer here is negative 1. Okay, another way to check this is you can do 102 divided by 4, and you get decimal of 0.5, and then here's your chart, 0.5, which is equal to negative 1. Okay. All right, what about 141? Try this one. Just get rid of the 0 part and see if you get your answer. Just I mean, when I said I, didn't I? When you see a negative under your radical, just write I. Okay, don't have to write too much. Don't have to write square root of negative 1 and all that. And then what is the square root of 16? 4. Just write that out. And then the x and y, there's nothing I can do with it. So that stays under my radical. I just keep it there. And I'm just going to rewrite this. 4 times I is just 4i. So I'm going to rewrite it like this. And I'm done. Okay? How do you want to check this in your calculator? Well, I go to my calculator. You know, I put in my original question. Let me clear all this out. I plug in square root of negative 16. And I can put in the x. There's an x right here. I can even put in a y. The y is somewhere over here, right? It's in green. So you can hit alpha 1 and you have the y, and it's not going to work because, and remember, in your calculator, you have to tell your calculator what x is. You have to tell your calculator what y is. Do I have any, like, do I know what x and y is? So I can't. You can put it, and if I hit enter, I'll show you, like, well, how do I even read this answer? So it's not going to work. So what I do is I just put in just the number part of it. So negative 16. That's it. Hit enter. I get 4i, and then just rewrite square root of xy. There'll be later where we have to plug stuff in for x and y, and I'll show you that. But for now, since there's really nothing to put in here, I'm just going to just put it the number part. Okay, so for here, you know, you have to work this out. I don't want to go to that. I do want to just jump to the multiple choice question over here, number 6. Okay, so again, I'm just gonna, since it's a multiple choice, I'm just gonna just put the question, put in my answer choices, and see which one matches. But just remember that for A and B, just ignore that for now because there's nothing I can put in there for right now. So square root of negative 24, I get this decimal with the I. Now plug in your answer choice. So I have 4 square root of 6. Hit enter. It doesn't match, right? It doesn't match. It doesn't even have the I. So it can't be that. Let me try 2i. I forgot. What did I forget here for answer choice B? I forgot something. Oh, I forgot to put the square root of x. 2i square root of, square root of 6. There we go. That's my answer because it matches my original question. Okay. We have a multiple choice question, so I have this whole thing here, but I have some answer choices. What I can do in this case is, instead of like ignoring the radical part, what I'm going to do is I'm going to plug in an irrational number. I don't want you to you can plug in pretty much any number actually, but you know, if you plug in regular numbers like 0, 1, 2, 3, you'll end up getting same answers in here. So what I want you to do is I want to plug in the irrational number such as pi. Pi is an irrational number. In other words, it is a weird number, okay? So watch how I do this in my calculator and follow along. So what I'm going to do is, in my calculator, you know, when I'm plugging stuff in, I use the store button, right? So I'm going to bring up pi. It's right here under the clear and the blue. So hit second, that symbol. And then I'm going to use the store button. And I'm going to store it for x. Enter. Okay? You see how pi is equal to a weird number? And then what I'm going to do is I'm just going to plug in my question here. So I have square root of negative 75x, get out of your radical, plus square root of negative 12x. Okay? And then hit enter. And we get some number. What your calculator did was it plugged in pi for your x here. And then I'm going to go through my answer choices. So you have 7 square root of 3x. Is that the answer? Be careful. No, why not? Because of the I, yep. So that means it has to be 7i square root of 3. Hit enter. Yep. Oh, no, hold on. What did I do? Oh, I forgot the x. Thank you. And then there we go. That matches my original. So my answer is B. Up to problem number 8. So the way we do this problem is we have to pretty much, it's factorization here, meaning we have to factor out common terms. So remember that a term is anything that's being separated by addition or subtraction, okay? So don't write this down. I just wanted to circle the term. We have term 1 and then we have term 2 here. So I have 2 terms and what I'm looking for is common factors, okay? So what I'm going to just break this down. So I'm going to say this has the I because of the negative, and then you have square root of 4, square root of 2, and square root of x, not 2. 4 times 5 is 20. Square root of 5, and then square root of x. Here's my first term, minus, and then here's my second term. You have your I. How can I break down 45? 5 times 9, and then square root of x. Okay? Yeah, I can break down the 4, I can break down the 9, but I'm going to leave it like this because it's easier to simplify. What's square root of 4? 2. Multiplication, square root of 5, square root of x, minus, what can I simplify in this term? The 9. So that's I, square root of 5, and what's square root of 9? 3, and then square root of x. Okay? All right, before I put everything together, I have to look for common terms. What's the common term? Is I common between both of them? That's common, so I can factor that out. What else is common? Square root of 5 and square root of 5. So I can factor that out. What else is common? X, square root of x, square root of x, square root of x. And then once I factor out the common terms, you put your parentheses and just write whatever is left. What do I have left here? 2 minus, what do I have left here? 3. Okay, and then this, when I clean it up, I have I square root of 5x, just put both of them back in your radical, multiplied by, what's 2 minus 3? We can put those two together, which is -1, yeah, and then -1 means it turns this whole thing into a negative. Let me scoot over. I can't, okay. I square root of 5x. The last part for today's lesson will be about complex numbers, okay? Complex numbers are in this form, or they will always be written as a plus bi. You'll have the imaginary number I there, where a is the real part, meaning it'll be just a number, and then b is the imaginary, or I should say bi is the imaginary part. Okay, a is the real part, b is the imaginary part, and when you have put them two together with an addition or a subtraction, it is called a complex number. Alright, just wanted to look at this note here. Note that a plus this weird symbol, you say this as, the way you say this is plus or minus. Okay? And it has the word or, which means that it's two separate numbers. So it is the same as a plus bi and a minus bi. This is just writing both of them at one time. Okay? Alright, how do we deal with complex numbers? Meaning, how do we perform operations? Addition, subtraction, multiplication, division. I have the formulas, but if you take a look at the formulas, it's pretty easy. So if you have a plus bi plus c plus di, meaning they're all different numbers, you just add the real parts together. Okay? So you take the a plus the c, and then you add the imaginary parts together. Okay? Subtraction, same thing. You add or you subtract the real parts from each other, and then you subtract the imaginary parts from each other. Multiplication becomes a little bit more complicated, but you can use this formula here. And then division gets even more complicated, and this is the formula for division. Okay? Alright, so let's just go through some of these examples, and then the later examples you can plug this in your calculator. Alright? Alright, so here I have two complex numbers. I have 4 minus I, 3 plus 2I. You just have to put the real parts together. What is the real part here? 4. What is the real part here? 3. So 4 plus 3 is 7. Okay, 4 plus 3 is 7. And what is the imaginary number here? Negative I. What is the coefficient of I? What's in front of I? -1. Okay, so -1 plus 2 is 2. 1 I. Okay, so this is 7 plus I. Yep, that looks good. Alright, same thing here. When you're subtracting them, you do -2 minus 3, which is -2 minus 3 is negative 5 because of negative makes a positive. Blah, blah, blah. So this is negative 5 and then negative 4 minus negative 6, you get 2. So plus 2 and then you have your I. Multiplication, this is just that FOIL method that we learned previously, where you do 5 times 3, which is 15, yep, and then 5 times 6i is 5 times 6 is 30, and then you have your I, okay, and then negative 4i times 3 is negative 12i. And then negative 4 times 6i is negative 24. And then what's I times I? I squared. Okay? So this is where it becomes a little tricky. Well, I'm going to first put my like terms together. 30i minus 12i is... let me check. 30... I minus 12, 18? 18? Yeah, okay. 18i. So this, I just put these two together. Now this one, you have negative 24. I'm going to put parentheses here because I squared is equal to what? Let me go back to the previous page. And this is something that you should remember about I squared. Yep, I squared is negative 1. Okay, so that's something I do want you to remember because it becomes very useful. I squared is negative 1. So this is 15. I'm running out of space. 15 plus 18i plus 24 because you have negative 24 minus 1 times negative 1. You get positive 24. I'm still not done. Since 7, I'm just going to cross this out because it's the same problem as number 6. I'm going to use this space. What are my like terms here? 15 and 24. So what's 15 plus 24? 39. So this is 39 plus 18i. That's my answer. All right, the last operation, division. All right, so when you want to divide, when you're looking to divide complex numbers, we have to look at our goal. Our goal is to get rid of the I in the denominator. Goal is no I in the bottom. Okay, we don't want to have the I in the denominator. So what I'm going to do here is I'm going to multiply by its conjugate. Okay, so I wrote here what a conjugate is. If you look up here by the division, all it is you take the opposite sign. So if you have A plus BI, the conjugate would be A minus BI. Don't change the real part, only change the imaginary part. And then again, likewise, if you have A minus BI, the conjugate would be A plus BI. Okay? So if I'm telling you to multiply numerator and denominator by its conjugate, what is the conjugate of 3 minus 2i? 3 plus 2i. So you're just going to multiply by the conjugate on top and bottom. Okay? And then we're going to do this. All right, let's go ahead and take our calculator's help at this point. So here you have to, I'm multiplying it, so I have to do 5i times 3 plus 2i. 5i times 3 plus 2i is, it should give me my answer, negative 10 plus 15i. Okay, and then divided by, let's see what I get in my denominator. 3 minus 2i and then 3 plus 2i. Okay, hit enter and I got 13. You see how when I do this, you should be able to just get a number in the denominator. I don't want it to have a complex number down here. So this is 13. Okay, and why not? Why can't I'll just go ahead and torture you more. In your answer choice, they'll write it like this. They'll say negative 10 divided by 13 plus 15i divided by 13. Okay, so this is my final answer. All right, again, so just do problem number 5, 6, and 8, and then just know that you can use your calculator on this.